Okay, so this is on slopes of lines, and you should have had some on slopes of lines in Algebra 1. Okay. First, in math, we always define the slope of a line using the letter M, and the definition for slope, definition of slope of a line is the rise over the run. The rise is the up and down value, the run is the horizontal value. Okay? So this is the definition of slope. I don't know why they use M for slope. I'd have to look that up. I have no idea why. Okay. Let's look at now on your paper. You're just going to do a sketch. You're just basically going to draw an X and Y axis. Okay, and let's say you put a point. It's actually go on your X and Y axis. Just go over 2 and go up 3 and put a point. Okay. Okay, then on the next one, go over to 4 and go up to 6 and put a point. Okay. Now, if we connect those with a line, okay, one way to figure slope is to use that definition. Okay, and when you use the rise over run, okay, you connect those 2 points with a triangle. Okay, you can go above the line or below the line. Okay, this is the rise, the up and down value is the rise, and this is the run. Now, it makes a difference. If I start at this point and go to the right, I'm going to the right 2 spaces, that would be a positive 2, and I'm going up 3 spaces, that would be a positive 3. So if I do this slope, rise over run, okay, I would end up with a positive 3 and a positive 2, so my slope would be 3/2. If I start at this point and go down, count spaces going down, I'd end up with a negative 3 and then a negative 2 to the left. But what's a negative divided by a negative? Still a positive 3/2. Okay? Now, it does not matter if you draw that triangle above. Like if I go above here, I can do the same thing. If I start at this point and go up 3, the rise would be 3, positive 3 going up, and to the right, positive 2, so still rise over run would be 3/2. If I start at this one and go left a negative 2 and go down 3. So any of those directions, you're still going to get the slope of this line is 3/2. And notice the way this line tilts. Anything that tilts in this direction, anything that tilts this way is going to have a positive slope. Okay? So that's doing the rise over run. Okay, let's do another one. Okay? On this one, let's go 3 to the left, so that'd be like negative 3. Okay, on this one, let's do a point at negative 3, or negative 3, positive 3, sorry. Negative 3, positive 3. And then let's do a point at negative 2 and negative 2. Okay? So it would look like that. And then if you connect those, okay, this one should have a negative slope. If I connect those with, do a horizontal and a vertical, and it doesn't matter which point you start with. If I start with this point, okay, and count up, the rise would be 1, 2, 3, 4, 5. You count spaces. So on this one, slope is rise over run. So the rise would be a positive 5, and the run would be a negative 1 to the left. Okay, so slope would be negative 5. Okay, if I go from this point and go to the right 1, that'd be a positive 1, but then I would go down 5, okay, and my slope would still be negative. So any line that tilts in this direction, okay, I don't care where you're at on the graph, if it tilts this way, that's kind of a last check, you're going to end up with a negative slope. Okay? Okay, in the upper level math, they will use that formula rise over run. But in some math books, they will use, this is the Greek letter delta, delta y over delta x. That Greek letter delta stands for the change in y, which that's the rise, the up and down values, count spaces, over the change in x, and that's the run. Okay. We also defined it in algebra as if I give you two ordered pairs, if I give you an ordered pair x sub 1, y sub 1, and the other ordered pair x sub 2, y sub 2, if I give you two ordered pairs, you should know the formula for slope is the difference in the y's, y sub 2 minus y sub 1, over x sub 2 minus x sub 1. Am I right? You've seen that formula before from Algebra 1? Okay. So, I don't know if we've done slope in here yet or not. I don't think so. We did the midpoint formula where we added them and divided by 2. We also did the distance formula. Distance formula where you subtract them. Yeah, and okay. Okay, so they will give you problems like this in the book. Say they ask you to find the slope of the line through the ordered pair negative 3, 7, and the ordered pair negative 1, 2. Now, so far you have two methods to do this. You could graph it, okay, but if you don't have graph paper, you don't have to graph that. You can just use the formula. And I'm a firm believer in write the formula down, substitute in. So m equals y sub 2 minus y sub 1. It's always the rise, and that's the up and down values, over the run, the x sub 2 minus x sub 1. Take either one of those ordered pairs, I don't care which one, label one of them x sub 1, y sub 1. Okay, and label the other one x sub 2, y sub 2. You have to have an x and a y in both ordered pairs. Okay, and then you fill into this formula. My y sub 2 is 2 minus, the minus sign's in the formula. My y sub 1 is 7. My x sub 2 is negative 1 minus, now my x sub 1 is a negative 3. So it's minus a negative 3. Now it's a matter of you've got to know your positive. Now you can change it on the next step. Yep. And on the, think about a number line too. 2 minus 7. What's the rule for subtraction? To subtract, we add its opposite. We add the opposite. So that's the same thing. You can think of that as, if you want to, as 2 plus a negative 7. Okay. Or if you already know what the answer is, okay, and minus a negative, same thing as adding a positive. So this one, you're adding a positive and a negative, so you take the difference of the numbers would be 5 and the sign of the larger one. 7's larger and it's negative. Okay, and take the difference of the numbers, and the 3's larger, so it's positive, so 2 is positive. Okay, so you should end up with the slope of this line is negative 5/2. And if I was doing this on a test, I would do it that way, and then I would come back and I would graph it on graph paper and do rise over run. I better get the same answer both ways. Yeah.
Why did you do the 2 plus negative 7? Do you have to do that?
No, no. Only if you need to do that. Okay. If you can go 2 minus 7's negative 5, you're good. Okay. Okay. Let's try another one. Okay, say they ask you to find the slope of the line through the ordered pair 0, 5 and the ordered pair 0, -4. Okay. So if we do this, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You should always write the formula down. Label one of those x sub 1, y sub 1, and the other one x sub 2, y sub 2. I could label this one x sub 1, y sub 1, and the other one. Just be consistent when you label it and then substitute in. So my y sub 2 is -4 minus my y sub 1 is 5. Okay, my x sub 2 is 0 and my y sub 1 is 0. And so I'd end up with a -9 divided by 0. Can you divide by 0? No. Division by 0 is undefined. So on this one, this is undefined. So this one is no slope. If it's undefined, it is no slope. Okay? No slope. No slope. Okay, and then if you graph this, 0, 5, 0 to the right and up 5. Okay, and 0 to the right and down 4. Okay, you end up with what type of line? Yeah, so any vertical line has no slope. And there's a difference between 0 slope and no slope. Okay? So vertical line, if you know it's a vertical line, you don't have to go through the equation. You can just say it is no slope. Okay, that is a special case. Okay, this is the other special case. Okay, if they ask you to find the slope of the line through the ordered pair -3, 9 and the ordered pair 3, 9. Okay? And if you use the formula m equals, the more you write this formula down, the better off. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Label either one of those x sub 1, y sub 1, the other one x sub 2, y sub 2. Okay, you just got to remember you got to have an x and y in both ordered pairs. So my y's would be 9 minus 9, and then the x sub 2 would be 3 minus a -3. So I end up with 0 over 6. 0 divided by anything except 0 is 0. So on this one is also a special case. If you graph this one, if you go -3 to the left and up 9, and if you go +3 to the right and up 9, okay, you're going to get a horizontal line. So any horizontal line is a special case. Any horizontal line has 0 slope. And I always tell people the easiest way to remember the difference between no slope and 0 slope is if you think about the horizon and think about the sun on the horizon, a horizontal line always has 0 slope. That'll help you remember it. Okay? So vertical line's no slope, horizontal line 0 slope, and you don't have to use those, okay, equations if you already know the cases. Okay. Okay. Then the author takes you through two postulates. Okay. Okay. Postulate 3.2. Okay. And it says two non-vertical lines. Remember that prefix non meaning not, so they are not vertical. Two non-vertical lines have the same slope if and only if, and most of the time in math, they're going to abbreviate that if and only if with an IFF. IFF, if you see it from now on, it's the shortcut way of writing if and only if. If they are not, think about this, if they're not vertical, the only way they're going to have the same slope is if they're what kind of lines? If they're parallel. If they are parallel. Okay, and you can use the word parallel, or remember the two lines like that, okay, means parallel, okay, without the parentheses, okay. Okay, and the last is postulate 3.3. Says two non-vertical lines are perpendicular two non-vertical lines are perpendicular. Remember the symbol we use in math for perpendicular lines looks like that. IFF, if and only if. The product of their slopes, product means multiply, the product of their slopes is -1. Okay, so they will write that the slope of the first line times the slope of the second line equals -1. An example, if I said the slope of one line was 3/4, what's the slope of the line perpendicular to it? -4/3. You got to do the reciprocal and the opposite. So they are negative reciprocals of each other. It's got to multiply together to give you -1. So if I said the slope of one line was -2/5, the one perpendicular to it would be -5/2. It's already, this one already had the negative, so 5/2, and that would give you -1. So those two lines would be perpendicular, and when you graph them, that's how they should look like. They have a 90-degree angle in the middle. Okay.